Yeah.
All right, yeah, you can still see it. So there's our two numbers that are not in the domain. Okay, so now to write the answer to the question, find the domain, it's all reals except -6 and -1. Okay, you can write it as a sentence, or the other way you can write it is with the parentheses. You could pick any number from -infinity up to -6, but can you include -6? No. Or you could pick a number between -6 and -1, again, not including either one of them, or from -6 to infinity. And that's the other way you could write the answer.
So when you have two x's as like an answer, will you always have like 3 like sets of
Parentheses? Yeah. Yep.
So why is it 6? That's
Yeah, why do you only use -1 once?
yeah, that's what I'm
Let me make sure I didn't mess up. So -infinity to -6. -6, yeah, that should be -1. Sorry. So you can pick anything from -infinity to -6, or -6 to -1, or -1 to infinity. Yeah. Any question on how you find the domain or how you write the two answers? Which way I'm going to have you write it? Well, it depends. Okay, I could have you just write it as a sentence, or if it's a multiple choice question, I might write it like on the bottom. All right, so that's domain. Sketching. Do we want to look at a sketch?
Yes,
Yeah,
please.
Sketch? All right. So let's sketch. Let's try, and this is one where you're going to have a slant asymptote, so we're going to have to divide. So I'm not sure how messy it's going to come out because I'm going to make it up. Let's try x squared minus 3x plus 1 divided by x minus 4. Okay, so I want to sketch that. All right, I think the first thing is we should be able to determine the vertical asymptote. Okay, where's the vertical asymptote?
Denominator.
Yeah, you look at the denominator, and it would be 4. Okay, so when I sketch it, I'll sketch that in a second. Now I want to find the slant asymptote. Is this the kind of problem I could use synthetic?
Yeah.
I could, yep, but you might not always be able to. So do you want me to use synthetic or long division? Long division, yep. So x minus 4 on the outside, you're not missing anything. X squared minus 3x plus 1. All right, what's the first thing you have to do here? Divide what? Divide that by that, and what does that give you?
X.
X, and now what do you do with the x?
Multiply it by x minus 4.
Multiply it back out. X times -4 is -4x. And now what are you going to do with your columns? Subtract. X squared minus x squared. What's -3x minus 4x? X. You can bring down the +1, but you're not going to need it unless you want the remainder. It's not important. So the last step is x divided by x.
Oh wait, no, just one.
Positive 1. That's your end behavior asymptote. Okay, there's another problem on the test where I ask you just to find the EVA, so I'm not going to go through that again. So any questions on how we just found the EVA?
So EVA is just when you divide.
Just when you divide it, yep. And now this particular problem, I needed that for the sketch. All right, so that's a line with a slope of, what's the slope on my EVA? 1. And the y-intercept? 1. So start at 1, and then go up 1 and over 1. Sketch that, and that's your EVA. On the test, I'm going to ask them to make sure you put the asymptotes dotted, so I can tell that's an asymptote. And I had a vertical asymptote at 4. Okay, so put a vertical line at 4. Now what I've done is I basically created an X shape with those asymptotes, and my graph is going to be in 2 of the sections. Okay? We have to figure out which 2 sections it's going to be in. For that, we use the table. Okay, so type in your problem. X squared minus 3x plus 1 minus 3x plus 1 and divided by x minus 4. Okay, so what I'm going to do is I'm going to try some values close to 4 first. What would be a value that's a little smaller than 4?
3.
3 point what?
9.
Even closer.
3.9.
Yeah, let's go really close. 3.99.
Wait, what did you divide it by? I'm sorry. Like your problem?
X minus 4.
Okay.
So, when you plug in, just look at the blue column, ignore the red column. When you plug in 3.99, you get a very negative number. Okay. So, just before the vertical line, because the vertical line's at 4, just before it, way down there. Okay. What about just after it? What would be a number after 4?
4.01.
4.01. If I go just after 4, I'm way up at 500. Okay, so just after the vertical line, way up here. And because my grid goes to 10 in each direction, maybe I'll try, I don't know, 5, 6, 7. Let's try, let's get 5 and then 8. Let's get a couple more x values over there. All right, so 5, I'm at 11, which means I'm off the graph. Let's try 6. Just barely. So 6, I'm at 9.5. 6, 9.5. So what's going to happen here is it's going to come down. It's very close to that green line. It's going to start to curve. And it wants to keep heading to the right, but it can't because it's going to hit that slant asymptote. So it's going to force it to do something like that. And that slant asymptote would just continue on. Okay, so that's what's happening in that section. Any question on that? For the other section, I've got 1 point. Let me try 1 and 0. That'll give me a couple more points. So 1, 1/3. So 1, 1/3. Let's do 0. 0, negative 0.25. All right, so now I can kind of see what's going to happen. It's going to come up, it's going to curve, and come back down. Okay, so it comes up. I'm not sure how high it goes. If I wanted to know, I could try another point, but just for the sketch, this is good enough. It's going to curve and get closer and closer. It's not perfect, but pretty close.
So when do you know if it's going to be a slant?
You know it's going to be a slant if you look at the number in the top and the bottom, and they're 1 apart.
Okay.
So like if the number at the top was a 5 and the one in the bottom was a 4, that would be a slant. If it's more than 1 apart, it wouldn't be a slant.
It would be that.
It would be something different, yeah.
Are there any ones in the test or the ones where you have like 6 columns and the one in the middle you have to do like...
I would focus on that type.
Okay.
So couldn't you just like realistically just graph it and then just draw it to where the graphics
I am going to look to make sure you give me the asymptotes. So the calculator can't tell you, ignore the line in red.
But for the graph itself, like our lines,
Mm-hmm.
like those lines, we can just put them into the calculator
Yeah.
and then just do the asymptote.
Yep, you gotta show me how to solve for the asymptote. So I'm just going to look for that.
Yeah.
So if you just have the right graph without any of the algebra stuff, you get half.
So when would you use like these types of graphs?
The one that's in 3 parts, so that's That's what someone just asked about, so you don't have to worry about that.
Oh, okay.
That one would happen when you have two vertical asymptotes.
Okay.
That's a little more complicated. This one you're not seeing very much because the screen cuts off right here on my calculator, so all you're seeing is that tiny little section. If you zoom out, you'd see some more of it.
What was the EVA is the same as? Wasn't it the same as something?
It can be the same as the NVA. Oh, it's the quotient. It's the same as the quotient. So the quotient is the EVA. All right. So any questions on the sketch there? Okay, so that's the sketch. EVA we just talked about. Let's just look at something like this. So I'm going to make up a sketch here. I'm not going to make up an equation because it'll be quicker if I just do a sketch. Okay, let's say you had some problem I gave you on the test. You type it into your calculator and that's what it looks like. And that's the graph of f of x. The question is the solutions to where that equation equals 0 are in which interval? So I'll just give you some choices. Are they in the interval from, let's say, 0 to 5? And I'm talking about all the solutions, not just one or two, all three of them. Are they in the interval from, let's say, -3 to 0? I'm just going to make one more choice, or -8 to 8. Which interval there would contain all the places where it crosses the x-axis?
-8 to 8.
Yeah. The first one contains one of them, 0 to 5, that's right there. -3 to 0, that contains one of them. But -8 to 8 is that interval right there. And that contains the three answers. Okay? So I'm not asking what the answers are, I'm just asking where are they? And they're somewhere in that range, -8 to 8. Okay, so there's a question just like that, and that's all you have to do. The only difference is you're going to be given a formula, you're going to have to graph it yourself on your calculator. Okay, so you'll have to type it in.
For the formula, are we just gonna have to type it in, or are we gonna have to like solve?
No, you're just going to have to type it in.
Okay.
Yep. I'll give you an equation, you type it in, it'll look something, it'll be a picture of something.
Okay.
And I'm basically looking for the interval where those three things are.
Okay.
So that was not too bad. Let's look at this one. Okay, here's another one that I'm going to give you a formula, but to make it quicker, I'm just going to graph something. So what's this one, number 7? So I want to know what happens to f of x, and what letter is that really?
Y.
Y. So I want to know what happens to y as x approaches 2 from the positive side. So what happens to y as x approaches 2 from the positive side? So here's your negative side. Here's your positive side. So as we start to approach 2, what's happening to y? And what's it getting close to? Negative what? Infinity. Yeah. So f of x is approaching negative infinity. Now, what if I worded the question, what's happening to x as you approach 2 from the negative side?
Increasing input.
Yeah. It's going to infinity. As you approach 2 coming from the negatives, okay, so coming from the left side, all of a sudden your y value goes to infinity. Okay, so I'm just checking to see if you understand that notation. That's all. Okay, so it'll be a question similar to that. Any questions on that one? All right, let's make up another one. So we talked a little about local mins and maxes. I think we did last night in the homework. So, actually, let me do it on here. The question is going to be, how many local minimums does the graph I'm about to show you have? All set. All right. So we're going to look at that graph. We're going to figure out how many local minimums it has. So, can you see clearly what's happening there? No, what do you have to do? Yeah, we got to zoom out. So I'm going to set maybe my y min to, what would be a good value?
Negative 30 maybe.
All right, let's try negative 30. We still are not going to be able to see if there's a maximum, but the question's not asking about that. All right, can we see it now?
Yeah.
Yeah. So how many local minimums are there? Just one. How do you know that the graph doesn't do something like this off the screen and have another minimum that we can't see? Yep.
Because it's an x cubed equation.
Yep, it's an x cubed equation.
It's twice.
Right, if you were to FOIL all this out, it would be an x cubed. X cubed can only turn twice. Well, I know there's one turn in here, there's the other turn there. There are no other turns that could be hidden off the screen. That's it. So any question on the local min? So the big thing is you've got to zoom out because there might be something hidden off the screen. All right, so that's that. All right, next two questions. We talked about the concentration, okay, for the acid. Any questions on that one? Like finding the concentration of a solution? Anyone need to see
Hannah's
that?
saying yes.
Maybe?
Yeah, can you just start real quick? I have to leave soon. Speak.
That's all right. So, I forget what number we're on, but that's fine.
8.
8. So let's just say you have 60 ounces of a 20% solution. I want to find a formula for C of x where this is the concentration. And what I'm going to do to that solution is I'm going to add pure acid to it, some unknown amount. So let's add x ounces of acid. All right. So remember your formula for concentration is how much acid you have over the total. So you're starting with 60 ounces, but out of the 60 ounces, only 20% is acid. So how do you find out how much acid is in the 60 ounces?
Times point.
Oh yeah.
60 times 0.20. So there's 12 ounces of acid in that solution. Plus, how much acid are you going to add to it?
X.
Here says you're going to add X ounces. So if you do that, that's how much acid you'd have. And how much total liquid are we starting with?
60.
60. And what are we adding to it? X.
Sorry, where are you getting the 12?
60 times 0.2.
Oh, okay.
Because you have 60 ounces, but only 20% of that is actually acid. Now, if you graph that, it's going to look something like this. It's going to look like a curve that goes up. The more acid you add, the higher the concentration goes. So now, if I said something like, tell me when you would have a 50% solution, how would you do that using the calculator? Yep.
Can you just use trace and then, or like, You hit like a button and then you hit.
No, don't you just plug it in and then on the second line you put
Yeah. On Y1, you plug in that. And then on Y2, well, you can't plug in 50. You'd have to plug in 0.5. And if you do that, you're going to get a picture that looks like this. Wherever they cross,
and then you find it here.
and then you find the intersect.
Okay.
And that's the answer?
And that would be the answer.
So, oh wait, never mind. Okay, thanks.
So any question on the concentration? All right, so vertical asymptotes, we did that. So last two questions. Yep, I'll say. Okay, transformations. Let's say you had this. 2 plus 3 divided by x plus 1. Compared to this, how many transformations are happening?
2, 3.
Three things that are happening there. Another way, if it's confusing like that, is you could think of it like this. That's the same way. So, anybody know what you would start with there?
What are we looking for?
The transformations.
Are we gonna have to do the transformations?
See you, Hager.
Yep, have a good day.
Oh wait, I have this.
We made a list of these way back of the order you should
Well, I know
always
that
start
the
with.
2 mean it's what?
Don't you find?
Yep, that's a shift up 2, and that's going to be the last thing.
And then the 1 is left 1.
So vertical shift up 2. Always end with your vertical shift.
And then you find the EBM, the EBA.
Nope, you don't need to here.
No. I don't know. I just have 3 things
Would
here.
step
and
2 be move left 1?
Step 2. Nope, your horizontal shift is the very first thing.
Step 1.
Horizontal shifts are always first. We did this in the section when we did parabolas.
Yeah.
I don't remember the number, but it was parabolas, chapter 2. So yeah, shift left 1. Okay, and just be careful with left and right. Okay, when you have a plus, you might think it goes right, but it's the opposite. And what about the 3? It's like you're multiplying by a 3 in front. What does that do?
I don't know that.
Yeah, I don't know either.
Does it control the amount of curves?
Not the amount of curves. It's not going to shift it, because we've already talked about the 2 shifts.
Is
It's
it
gonna,
going to increase or decrease it? Oh wait, how wide it is?
so it is going to stretch it. It could stretch it. It might be maybe it's wider or narrower, I don't know.
Vertical stretch?
But that's a vertical stretch.
Does it, if it's like a bigger number, doesn't that mean?
A bigger number would stretch it more. So you'd go from something like this to maybe something like that. Imagine like the bottom was fixed and you pulled up. It would get skinnier and taller.
So are we gonna actually have to like draw?
You're not going to have to draw it. You're just going to have to do these 3 things right there.
Alright.
Oh, you can put it on my desk. Yep, thank you. So vertical stretch by a factor of 3. If there was a number here, that would be a horizontal stretch. Okay, so number in front is vertical. Number right next to the x is horizontal. Plus or minus next to the x, that's a shift, left and right. Plus or minus away from the x, like way outside, that's a shift up and down. And up and down is what you would expect. Positive is up, negative is down. Okay, question on that? All right, so the last problem is what we did in class today. So something like, actually let's try this. So 3x over x plus 1, and I'm making this up, so it's possible the answers don't work, that they're extraneous. Minus 2 over x plus 2 equals, let's just try 5 over x squared plus 3x plus 2. Okay. First thing you want to notice, and this always happens in the kind of problems I give you, is if you factor this, what does it factor as? It factors as the other two denominators. Yep. So what would be the LCD in this problem?
X plus 1, X plus 2.
X plus 1, X plus 2. So you're going to multiply everything by what Hannah just said. X plus 1, X plus 2. Don't do it out until you cancel first. Okay, what cancels on the first fraction?
X plus 1.
Second fraction?
X plus 3.
Third fraction?
Both.
Whole thing. So on the right, you're just left with 5. On the left, that's a distributive.
3x squared plus 6x.
And now be careful with this distributive. Some people make the mistake here.
Negative 2x minus 2.
Negative 2x minus 2. You're distributing that negative. That's with the 2. So negative 2x minus 2. Combine your like terms. 6x minus 2x. 4x. And we want to get it equal to 0.
Minus 7.
Minus 7. And now from here, I don't think that's factorable. You would use quadratic formula.
What's a quadratic formula again?
The quadratic formula?
Negative b plus minus square root of b squared plus 1.
So in this case, that's A, that's B, negative 7 is C. So you plug those numbers into that formula and get your answer. Any questions on how to do that part? Okay. So that's everything that's on the test in 30 minutes.